Here in this video, we are talking about a particular scenario. The scenario is like this. Let us consider a thin wire. It is fixed between two rigid supports like this. Now you heat up this wire. When you supply the heat, when you raise the temperature, this wire is supposed to expand, but you are not allowing it to expand because you have fixed it on both the sides. As you have fixed it in both sides, a stress is developed inside. That stress developed inside the wire because we have supplied the heat is called thermal stress. I want to calculate how much is that thermal stress is, right? So we can do that basing on the definition of Young's modulus of this wire. Assume this wire has a Young's modulus L of Y, horizontal length is L. When you increase the temperature, let its length is supposed to increase delta L, but that is restricted because it is fixed between two rigid supports. As for the definition of Young's modulus, it is the ratio of longitudinal stress to the longitudinal strain. So that is F by A, L by delta L is Young's modulus. That implies force by A area is called stress. This stress is generated because of the heat. Then that is called thermal stress. So thermal stress F by A equal to Y delta L by L, where delta L is the increase in the length. As for the definition of alpha of the given wire, alpha is defined as ratio of change in the length to its original length per 1 degree centigrade rise in temperature. So delta L can be written like alpha L into delta T, where L is its original length. So in the place of delta L, alpha L into delta T by L and L can be cancelled. So thermal stress force by area equal to Y alpha delta T is the expression that we are willing to derive in this video. But I want you to understand carefully that this thermal stress is independent of length of the wire. Whatever the length of the wire is, the stress is going to remain same. How much is the thermal force generated? If somebody asks you, F by A, we know, just take the area to other side. That becomes YA alpha delta T. So that depends on the area of cross section too. That's how we can think of thermal stress and the thermal force when a wire is fixed between two rigid supports. That's it. Thank you for watching.